Helion Energy's groundbreaking nuclear fusion power plant announcement. On February 27, 2025, Helion Energy, an innovative nuclear fusion energy company based in Everett, Washington, made a significant announcement. It plans to construct the world's first commercial nuclear fusion power plant in Malaga, Washington. This ambitious project aims to generate 50 megawatts MW of clean energy with an operational target set for 2028. The plant will be located near the Rock Island Dam on land owned by the Chelan Public Utility District (PUD), marking a pivotal moment in the quest for sustainable energy solutions. The announcement was made during a press conference held at the Confluence Technology Center in Wenatchee, where Helion representatives, including Communications Director Jessie Barton, outlined the project's potential impact on the local community and the energy sector at large. Barton emphasized the importance of community engagement and the company's commitment to transparency, stating, "We are looking at developing a 50-megawatt fusion power plant, and we are ready to bring in more community members to have a larger conversation about this potential project." Microsoft partnership. In a groundbreaking move that underscores the commercial viability of fusion energy, Microsoft has already signed an agreement to purchase the plant's first kilowatt-hour of electricity. This partnership aligns with Microsoft's sustainability goals and highlights the growing confidence in Helion's technology. The fusion energy produced by the plant is expected to significantly contribute to powering Microsoft's data centers, facilitating the company's transition to cleaner energy sources. Community engagement and plans. Helion Energy has planned a public event on March 11, 2025 at Mission View Elementary School, where local residents can learn more about the project and provide input. This event will be crucial for addressing any community concerns and fostering a collaborative atmosphere as Helion moves forward with its plans. If the permitting process proceeds without delays, Helion aims to begin construction by summer 2025 with a projected completion date for energy production set for 2028. The company anticipates hiring approximately 130 workers during the construction phase and around 30 employees for ongoing operations once the plant is operational. Financial backing and development progress. Helion Energy has secured substantial funding to support its ambitious project, raising $425 million in a Series F funding round, bringing its total funding to over $1 billion. This financial backing is crucial for developing the technology necessary to make commercial fusion energy a reality. Investors' confidence reflects a growing belief in the potential of nuclear fusion as a viable and sustainable energy source. Technical challenges and competitive landscape. While Helion is poised to make significant strides in fusion energy, it faces competition from other entities in the field. The technical challenges associated with nuclear fusion, such as achieving sustained reactions that produce more energy than they consume, remain formidable. Recent achievements by other facilities, such as China's record of maintaining a fusion reaction for 1,066 seconds and the West Tokamak in France surpassing that by an additional 271 seconds, illustrate the ongoing race to achieve practical fusion energy. Conclusion. Helion Energy's announcement marks a potential turning point in the energy industry, with the possibility of commercial nuclear fusion becoming a reality. The partnership with Microsoft not only provides a robust financial framework but also highlights the interest and viability of fusion energy as a clean energy source for large corporations. As Helion prepares for community engagement and the construction of the fusion power plant, the world watches closely to see if the artificial sun is truly on its way to lighting up homes and businesses by 2028. This project represents not only a technological milestone but also a hopeful step towards addressing global energy demands with clean, sustainable solutions. With Helion at the forefront, the future of energy may indeed be brighter than ever. Helion Energy's announcement to build the world's first commercial nuclear fusion power plant in Malaga, Washington has generated significant interest and excitement. However, several counterintuitive elements emerge from this development that deserve attention. 1. Commercialization of fusion energy. While nuclear fusion has long been viewed as a futuristic energy source, Helion's decision to pursue commercialization by 2028 is surprisingly aggressive. Historically, fusion energy has been relegated to research institutions due to its technical complexity and the challenges of achieving net positive energy output. The notion that a private company can pioneer this technology to the point of producing electricity for commercial use in just a few years defies the typical timeline associated with energy technologies. 2. Microsoft's role. Microsoft's early commitment to purchase the first kilowatt-hour of electricity from Helion's plant is intriguing. Typically, large tech companies like Microsoft have focused on renewable energy sources such as solar and wind to meet sustainability goals. The decision to invest in fusion energy, which is still largely experimental, raises questions about the reliability and scalability of this technology compared to more established renewable sources. This partnership may signal a shift in how tech giants view energy sourcing, moving towards a more diversified approach that includes potentially transformative technologies like fusion. 3. Community engagement versus project viability. Helion's plans for community engagement, including a public event to discuss the project, suggest a commitment to transparency and local involvement. However, the reality is that significant infrastructure projects often face local opposition due to fears of environmental impact and change. The juxtaposition of Helion's intentions to engage the community while aggressively pushing forward with a strict timeline for construction raises the question of whether such engagement is genuinely impactful or merely a procedural formality. Historically, community input has been overlooked in similar projects, leading to backlash and regulatory hurdles. 4. Funding and technical feasibility. Helion's substantial funding of over $1 billion, including a recent $425 million Series F round, positions it well financially. Yet the reality of developing a functional fusion reactor remains fraught with technical challenges. The technology must demonstrate not just the ability to initiate fusion but also to sustain it long enough to generate usable power. The fact that Helion is making progress in this area while competing entities like those in China and France have achieved significant milestones themselves presents a paradox. One could assume that with such funding, breakthroughs would be more guaranteed, yet the history of fusion research is littered with ambitious projects that failed to deliver on their promises. 5. Local energy strategies. The Chelan Public Utility District's PUD involvement indicates a strategic shift from traditional hydropower to a more diverse energy portfolio. However, the region has relied heavily on hydropower for decades, and the transition to fusion energy could destabilize existing energy frameworks. The local push for diversification might seem prudent and proactive, yet the heavy investment in an unproven technology poses risks that could outweigh the benefits, particularly if the fusion project does not meet its operational timelines or energy output expectations. 6. Competition in the fusion space. The competitive landscape for fusion energy is often underestimated. Helion is not alone in its pursuit. Other countries and organizations are making significant strides. The expectation that Helion will be the first to deliver commercial fusion energy is not guaranteed given the rapid advancements made by international competitors. This reality highlights a broader trend where expectations of innovation and leadership in technology can be rapidly surpassed, rendering initial advantages obsolete. 7. Public perception of fusion energy. There exists a common perception that fusion energy is the holy grail of energy solutions due to its potential for clean, abundant power. However, the complexities involved in achieving a viable fusion reaction challenge the simplistic view of fusion as a near-term solution to energy needs. The optimism surrounding Helion's project contrasts sharply with the historical skepticism that has accompanied fusion research, indicating a societal shift in how we perceive the feasibility of advanced energy technologies. Conclusion. Helion Energy's initiative to construct a commercial nuclear fusion power plant is a multifaceted development that reflects both the potential and challenges of advanced energy technologies. The counterintuitive aspects of rapid commercialization, corporate partnerships, community engagement, and competitive dynamics underscore the complexities involved in bringing fusion energy from concept to reality. As the project unfolds, it will serve as a critical case study in the broader narrative of energy innovation and its implications for the future of sustainable power. The recent announcement by Helion Energy regarding the establishment of the world's first commercial nuclear fusion power plant in Malaga, Washington is monumental not only in the realm of energy production but also in its implications for climate change and technological advancement. While many aspects of this development have garnered attention, there are several nuanced elements within the report that could easily be overlooked yet hold significant implications for the future. 1. Community engagement and local involvement. One of the critical aspects that often gets sidelined in discussions about industrial developments is community engagement. Helion's plan to host a community event on March 11, 2025 at Mission View Elementary School is significant. While many reports highlight the technological and financial facets of the project, the emphasis on community input reflects a commitment to transparency and collaboration with local residents. This approach can help mitigate potential opposition or concerns about environmental impacts, safety, and the socio-economic effects of the plant. Significance: engaging the community can lead to greater public support and a smoother permitting process. It also allows for local concerns to be addressed proactively, which is essential in fostering a collaborative environment that can lead to successful project execution. 2. Microsoft's partnership and its broader implications. The partnership with Microsoft is a crucial highlight of Helion's project, as they have already signed an agreement for the first kilowatt-hour of electricity from the fusion plant. This milestone not only signals a significant commercial interest in fusion energy but also underscores the alignment between Helion's technology and the sustainability goals of major corporations. Significance: Microsoft's commitment to purchasing fusion energy represents a shift in corporate energy strategies where large companies are starting to invest in and support clean energy sources. This could encourage other corporations to consider similar partnerships, potentially accelerating the development of the fusion energy sector and pushing traditional energy companies to adapt to a more sustainable model. 3. Funding and investor confidence. Helion has successfully raised over $1 billion with a recent $425 million infusion in a Series F funding round. While many reports mention this substantial financial backing, the implications of such investor confidence are often underexplored. This level of funding indicates a strong belief in the viability of fusion energy technology, which has historically been viewed with skepticism due to its technical challenges. Significance: this financial backing not only supports Helion's immediate goals but also serves as a signal to the broader market that fusion energy is gaining legitimacy. Moreover, it could inspire other startups in the clean energy sector to pursue innovative solutions, knowing that significant investment is possible. 4. The technological challenges ahead. While the excitement surrounding the potential of fusion energy is palpable, the report does touch upon the significant challenges that remain. The need for Helion to demonstrate that its system can deliver usable electricity efficiently is paramount. Other facilities around the world, like those in China and France, have recently achieved impressive milestones in sustaining fusion reactions, which highlights the competitive landscape. Significance: the race to achieve a commercially viable fusion reactor is not just about technology, it is a matter of national and international prestige. The ability of Helion to overcome these technical challenges will determine whether it can maintain its lead in the fusion energy race. The mention of other countries' advancements serves as a reminder that global competition in clean energy technology is intensifying. 5. The environmental impact considerations. The project is planned to be located near the Rock Island Dam, a site with its own ecological significance. The need for an environmental impact report is a critical step that could shape the project's timeline and scope. However, the potential environmental implications of constructing and operating a fusion plant, especially in proximity to a major waterway, may not be sufficiently addressed in public discourse. Significance: the environmental considerations could affect local ecosystems and the long-term viability of the project. Ensuring that the plant operates within ecological limits is essential for securing community support and regulatory approval. Furthermore, the project's success in mitigating any negative environmental effects could set a precedent for future energy projects. 6. Job creation and economic growth. The anticipated creation of approximately 130 construction jobs and 30 operational positions, while mentioned, may not receive the attention it deserves. The economic impact of such a project on the local community can be profound, providing not just jobs but also opportunities for local businesses. Significance: job creation is a tangible benefit that can help garner local support for the project. It also underscores the broader economic potential of the fusion energy sector, which, if successful, could lead to further investments and job growth in related industries, such as manufacturing technology and environmental services. Conclusion: Helion Energy's plans for a nuclear fusion power plant represent a pivotal moment in the energy landscape. While the overarching narrative focuses on technological innovation and corporate partnerships, it is essential to consider the subtler aspects of community engagement, environmental impact, and economic implications. These elements are crucial in shaping public perception, regulatory approval, and ultimately the success of fusion energy as a viable alternative to traditional energy sources. As the project progresses, these factors will play a significant role in determining not only the fate of Helion Energy but also the future of clean energy technology globally. 1. Location and capacity of the fusion plant. Helion Energy's decision to build its fusion power plant in Malaga, Washington marks a significant milestone in the pursuit of nuclear fusion energy. The facility is designed to have a capacity of 50 megawatts MW, which is a critical benchmark for commercial viability. The location near the Rock Island Dam provides access to existing infrastructure and could facilitate the integration of fusion energy with the local power grid. This strategic choice not only highlights the potential for clean energy generation but also emphasizes the technological advancements that Helion aims to achieve by 2028. 2. Partnership with Microsoft. The collaboration with Microsoft is a pivotal aspect of Helion's project as it signifies the commercial viability of fusion energy. By securing a purchase agreement for the first kilowatt-hour of electricity generated by the plant, Helion has established a tangible demand for its product. This partnership aligns with Microsoft's sustainability goals, demonstrating a commitment to reducing carbon emissions and transitioning to clean energy sources. The deal not only validates Helion's technology but also sets a precedent for future corporate engagements in the energy sector. 3. Community engagement and local impact. Helion's proactive approach to engaging the local community is essential for the project's acceptance and success. The planned community event scheduled for March 11, 2025 at Mission View Elementary School aims to involve residents in discussions about the fusion plant, addressing any concerns and gathering feedback. This focus on community involvement underscores the importance of transparency and collaboration in large-scale energy projects, ensuring that local stakeholders feel included in the decision-making process and can benefit from the anticipated economic opportunities such as job creation during construction and operations. 4. Financial backing and technological development. Helion's substantial funding of over $1 billion, including a recent $425 million Series F round, indicates strong investor confidence in its fusion technology. This financial support is crucial for overcoming the technological challenges associated with nuclear fusion, particularly achieving sustained reactions that generate more energy than consumed. The ongoing development of the Polaris reactor prototype is a testament to Helion's commitment to innovation in energy generation. The success of this project could potentially pave the way for further advancements in fusion technology shaping the future of clean energy. 1. The Manhattan Project 1942 to 1946. The Manhattan Project was a secret U.S. government research project during World War II aimed at developing the first nuclear weapons. Led by physicist J. Robert Oppenheimer and involving thousands of scientists, engineers, and military personnel, the project ultimately resulted in the creation of atomic bombs dropped on Hiroshima and Nagasaki in 1945. The project showcased rapid advancements in nuclear technology under intense pressure and secrecy, paralleling Helion's ambitious goal of developing a commercially viable fusion power plant. 2. The Apollo 11 mission 1969. The Apollo 11 mission marked the first successful manned mission to land on the moon, demonstrating extraordinary advancements in technology, engineering, and collaboration. NASA's commitment to reaching the moon within a decade, fueled by the Cold War space race, involved overcoming significant technical challenges. Similar to Helion's aspirations in fusion energy, the Apollo program required innovative solutions and high levels of investment to achieve a groundbreaking milestone in human history. 3. The ITER Project 1985-present. The International Thermonuclear Experimental Reactor ITER is a large-scale international collaborative project aimed at demonstrating the feasibility of nuclear fusion as a large-scale and carbon-free source of energy. Launched in 1985, ITER involves contributions from 35 nations and represents a significant scientific and engineering challenge. Much like Helion's plans for a commercial fusion power plant, ITER's goal is to eventually produce more energy than it consumes, which aligns with Helion's vision of harnessing fusion energy for sustainable power. The announcement from Helion Energy regarding the construction of the world's first commercial nuclear fusion power plant in Malaga, Washington, marks a significant milestone in the pursuit of clean energy. Set to begin operations by 2028, this project, backed by substantial funding and a partnership with Microsoft, could herald the dawn of a new era in energy generation. Here we predict the future trajectory of the nuclear fusion landscape, the potential implications for energy markets, and the role of technological advancements in shaping this vision. 1. Acceleration of fusion technology development. As Helion Energy moves forward with its plant, we anticipate a surge in research and investment in nuclear fusion technology. Other companies and consortiums globally are likely to intensify their efforts to achieve similar milestones spurred by Helion's progress. This could lead to a competitive environment where breakthroughs in efficiency and sustainability in fusion reactors become more frequent. 2. Impact on energy markets. The introduction of nuclear fusion energy has the potential to disrupt traditional energy markets significantly. Fusion energy promises to provide a nearly limitless source of power with minimal environmental impact. As fusion plants begin generating electricity, we expect a gradual shift away from fossil fuels and even renewable sources like solar and wind, particularly in regions where energy reliability is crucial. This shift could lead to a decrease in energy prices due to increased supply and competition, benefiting consumers and industries alike. 3. Enhanced energy security. With the successful deployment of fusion power plants, countries could enhance their energy security by reducing dependence on imported fossil fuels. Fusion energy can provide a stable and consistent power supply, mitigating the volatility associated with oil and gas markets. Nations investing in fusion technology may find themselves in a stronger geopolitical position as energy independence becomes a reality. 4. Community engagement and local economies. Helion's commitment to community engagement, as evidenced by their plans for public events, suggests that future fusion projects will prioritize local input and address community concerns. This could foster a positive relationship between energy companies and local populations, paving the way for smoother project implementations. Additionally, the construction and operation of fusion plants will create jobs and stimulate local economies, providing a dual benefit for regions hosting these facilities. 5. Environmental considerations. As the world grapples with climate change, the environmental benefits of fusion energy will become increasingly pertinent. Fusion produces no greenhouse gas emissions and generates minimal radioactive waste compared to traditional nuclear fission reactors. As public and governmental awareness of climate issues grows, support for fusion energy projects is likely to increase, leading to more favorable policies and funding opportunities. 6. Technological innovations spurred by fusion research. The pursuit of nuclear fusion will drive technological advances across multiple sectors. Innovations in materials science, plasma physics, and energy storage are just a few areas that will benefit from fusion research. These advancements could have far-reaching implications beyond energy generation, influencing sectors such as transportation, manufacturing, and even healthcare. 7. Integration with other renewable energy sources. While fusion energy holds promise, it is unlikely to operate in isolation. The future energy landscape will likely be characterized by a hybrid model integrating fusion with other renewable sources like solar, wind, and hydroelectric power. This synergy could enhance grid reliability and resilience, allowing for a diversified and sustainable energy portfolio that meets varying demands. 8. Global collaboration and knowledge sharing. The complexity of fusion technology necessitates collaboration among nations and institutions. As Helion and others make strides, we predict an increase in international partnerships aimed at knowledge sharing and cooperative research. Global initiatives could emerge to accelerate fusion development, similar to how countries collaborated on the International Space Station or the ITER project in France. 9. Regulation and policy frameworks. As fusion energy technologies mature, regulatory frameworks will need to evolve to accommodate this new form of energy generation. Policymakers will face the challenge of ensuring safety and environmental protection while fostering innovation. Clear guidelines regarding the construction, operation, and decommissioning of fusion reactors will be essential to gain public trust and support. 10. The long-term vision. Looking further ahead, the successful implementation of fusion energy could lead to a redefinition of energy consumption as we know it. The potential for decentralized fusion reactors providing localized energy solutions could revolutionize the way communities access power. Imagine neighborhoods powered by small-scale fusion reactors, creating self-sustaining energy systems that enhance resilience against grid failures and natural disasters. Conclusion. The journey toward harnessing nuclear fusion energy is just beginning, with Helion Energy's project in Malaga acting as a catalyst for broader advancements in this field. As we look toward the future, the successful deployment of fusion technology could not only reshape the energy landscape but also redefine economic, environmental, and societal paradigms globally. The coming years will be critical in determining whether the artificial sun is truly on its way, illuminating the path toward a sustainable energy future.